Okay, now we are discussing a continuous case. F of xy is equal to 3x plus 3y. X varies from 0 to 1, y varies from 0 to 1. One more condition is there, x plus y is less than or is equal to 1. In the previous case, there are only two conditions, condition for x, condition for y. One more condition is here, x plus y less than or is equal to 1 and equal to 0 otherwise. Here, x varies from 0 to 1, x-axis is here, y-axis, x varies from 0 to 1, y varies from 0 to 1. Next condition is x plus y less than or is equal to 1. For this you plot x plus y is equal to 1, x here, when x equal to 0, y equal to 1, y equal to 0, x is equal to 1. So a line passing through these 2 points, 1 0 and 1 0 and 0 1. This line is x plus y is equal to 1. X plus y less than or is equal to 1 means orientation is here towards this side. So x varies from 0 to 1, y varies from 0 to 1. X plus y less than or is equal to 1 implies function is defined only in the triangular region. This function assumes the value 3x plus 3y only in the triangular region. That's the difference here. So we are considering a triangular region. In the triangular region, 3x plus 3y, all our points function is equal to 0. Here, the marginal distribution function fxx, already defined in the previous class, fxx, is defined as integral over y f of xy dy. Integration with respect to y. Whenever you are considering marginal distribution function of x, integral over y, f of xy dy. So here y varies from where to where? Actually y varies from 0 to 1, only this straight line. All the remaining points you take a strip parallel to y axis. So all the time the below point is, the bottom point is 0 is always y equal to 0. So it is 0. The upper point is 1, just 1 only here. Here it is 0. So you take a strip here from the equation of this straight line, y is equal to 1 minus x. So y varies from 0 to 1 minus x. F of xy is 3x plus 3y dy. F of xy is 3x plus 3y dy. So the please understand the concept. Actually given that x varies from 0 to 1, y varies from 0 to 1, but actually y varies in the triangle, in this triangle y varies from 0 to 1 minus x. So interaction with respect to y, 3x is a constant, integral 1 dy is y, plus 3 into y square by 2 varies from 0 to 1 minus x. 3x into y plus 3 into y square by 2 varies from 0 to 1 minus x. 3x into 1 minus x plus 3 by 2 into 1 minus x the whole square. 3x into 1 minus x, y takes the value 1 minus x, y takes the value 1 minus x. Bottom point is 0, lower limit is 0, 0 minus 0 plus 0, 0. So it is 0. You take 1 minus x the outside, 1 minus x into 3x plus 3 by 2 into 1 minus x. That is equal to 1 minus x into 3x plus 3 by 2 minus 3 by 2x. That is equal to 1 minus x into 3x minus 3 by 2x is 3 by 2x, 3 minus 3 by 2 is 3 by 2 plus 3 by 2. That is equal to 3 by 2 into 1 minus x into 1 plus x. That is equal to 3 by 2 into 1 minus x square. 0 less than or is equal to x less than or is equal to 1. Marginal distribution function of x, fxx is equal to this one, 3 by 2 into 1 minus x square. Marginal distribution function of x. Next aim is to find expectation of x. Expectation of x. So here formula is integral over x, x into fxx dx. That is equal to x varies from 0 to 1, 0 to 1, 3 by 2 into 1 minus s square into x into 3 by 2 into 1 minus s square dx. 3/2 is a constant. X integration s square by 2, x into s square s cube, x raised to 4/4 varies from 0 to 1. So 3/2 is a constant. Integral x dx is s square by 2. Integral s cube dx is x raised to 4/4. That is equal to 3/2 into 1/2 minus 1/4. When x equal to 0, value 0, x equal to 1, 1/2 minus 1/4. 1/2 minus 1/4 is 1/4. 2/4 minus 1/4, 1/4. That is equal to 3/2 into 1/4 is equal to 3/8. So expectation of x is equal to 3/8. So formula once again, expectation of x is equal to sigma over x into fxx into fxx dx. In the previous module it was f of x, probability density function of x, here marginal distribution function of x. In a similar way, we are evaluating marginal distribution function of y. Marginal distribution function of y, fyy, integral over x, f of xy dx. So whenever fyy, integration with respect to x. Here x varies from where to where? X varies from beginning point is always left point is always 0, right point is always 1 minus y. So 0 to 1 minus y, 0 to 1 minus y, 3x plus 3y dx. That is equal to 3x square by 2 plus 3yx varies from 0 to 1 minus y. 0 to 1 minus y, okay. Then 3/2 into 1 minus y the whole square plus 3y into 1 minus y. We are taking upper limit x equal to 1 minus y, 1 minus y the whole square, x equal to 1 minus y. When lower limit 0, 0. You take 1 minus y outside there, 1 minus y outside, 3/2 into 1 minus y plus 3y, that is equal to 1 minus y into 3/2 minus 3/2y plus 3y, that is equal to 1 minus y into 3/2 minus 3/2 plus 3 is 3/2y. You take 3/2 outside, 1 minus y into 1 plus y is 1 minus y square. Y varies from 0 less than or is equal to y less than or is equal to 1. Whenever we define the marginal distribution function, we are taking the full range, not the specified range. So here y varies from 0 to 1. 3/2 into 1 minus y the whole square. Therefore expectation of y is equal to integral over y into fyy dy. That is equal to y varies from 0 to 1. Fyy is 3/2 into 1 minus y square dy. Y varies from 0 to 1. That is equal to 3/2 into y minus, y is there, y into 3/2 into 1 minus y the whole square. 3/2 into integral y is y square by 2. Y cube is y raised to 4/4, varies from 0 to 1. Answer is 3/8. The same case, 1/2 minus 1/4 is 1/4. 3/2 into 1/4 is 3/8. So expectation of y is equal to 3/8. Next concept is expectation of function having two variables. Here we are defining expectation of xy is equal to integral over x, integral over y, xy into f of xy dy dx. Inner integration first, then outer integration, so dy dx. So whenever we are taking the full function here, it is not possible to take x equal to 0 to 1, y equal to 0 to 1, because we are considering this triangle. In this triangle, either you can fix or you can fix y. So I am fixing x. So x varies from 0 to 1. This is fixed. X varies from 0 to 1. So y varies from where to where? Y varies along the strip, and y varies from 0 to 1 minus x. 0 to 1 minus x. xy is there. xy into 3x plus 3y. First iteration with respect to y, then with respect to x. First iteration with respect to y, then with respect to x. That is equal to integral 0 to 1. Integral 0 to 1 minus x. 3x square y plus 3x y square dy dx. So the most important point is x plus y less than or is equal to 1. We are concerning a triangular region. Whenever we are taking the whole function together, it is not possible to take x varies from 0 to 1, y varies from 0 to 1. You can fix either one of them. I am fixing x varies from 0 to 1, then y is a running variable, y varies from 0 to 1 minus x. Okay. That is equal to integral 0 to 1. Integration is with respect to y. 3x square is a constant. Integral y is y square by 2. Plus 3x is a constant. Y square is y cube by 3. Integration y square is y cube by 3. 0 to 1 minus x dx. Upper limit and lower limit. So integral 0 to 1, upper limit 3 by 2 x square into 1 minus x the whole square plus 3 cancels, x into 1 minus x the whole cube dx. Lower limit is 0 because 0 into 3, 0 into this quantity is 0, 0 into x is 0, therefore lower limit is 0, upper limit minus lower limit. So 3 by 2 into x square into 1 minus x the whole square plus x into 1 minus x the whole cube. Integration is with respect to x. Integral 0 to 1, 3 by 2 into x square into 1 minus 2x square plus x raised to 4, a minus b the whole square, a square minus 2ab plus b square plus x into a cube minus 3a square b plus 3ab square minus b cube, expanding 1 minus x the whole cube. So a cube minus 3a square b plus 3ab square minus b cube, that is equal to integral 0 to 1, 3 by 2 into x square 2x raised to 4 plus x raised to 6 plus x minus 3x square plus 3s cube minus x raised to 4 dx. Integrating (3 by 2) into x integral s square is s cube by 3. We are integrating. So 3 by 2 is a constant. Integral s square is s cube by 3 minus 2 x raised to 5 by 5 plus x raised to 7 by 7 plus x is s square by 2, 3s cube by 3 plus 3 x raised to 4 by 4 minus x raised to 5 by 5. Limit varies from 0 to 1. Solving, we will get expectation of xy is equal to 1 by 10. Expectation of xy is equal to 1 by 10. So what is covariance? Covariance of xy is equal to expectation of xy minus expectation of x into expectation of y. That is equal to 1 by 10 minus expectation of x is 3 by 8. Expectation of y is 3 by 8. So 1 by 10 minus 9 by 64. This is the covariance not equal to 0. X and y are not independent. Covariance of xy is okay. So our topic was covariance. So covariance is defined as expectation of xy minus expectation of x into expectation of y. Please go through the class. Please understand the difference between module 2 expectation of x and module 3 expectation of x, expectation of y. how to find variance, how to find expectation of xy. Today's class is over. We will discuss the other topics in next class.